Hello, this is Mr. Stansbury. I'm going to take you through the right angles in geometric figures notes. Okay. At the end of this, you should be able to say, I can make right triangles in certain geometric figures to help me find out more information about those figures. Okay. So first off, let's look at some special quadrilaterals. Okay. In a rectangle, the diagonal will create two right triangles. So you cut this in half and look, you got a right triangle here and you got a right triangle there. Okay. In a kite, the two diagonals intersect at right angles, so this diagonal and this diagonal make right angles here, and it also bisects this short diagonal. So this diagonal here is cut exactly in half. Okay. In both a square and a rhombus, the diagonals bisect each other at right angles. So you can see we've got a bunch of right triangles that we've made here as well. Okay, so using that information here, let's take a look at example 5 here. Part A is a kite has side lengths of 12 centimeters and 16 centimeters. Short diagonal is 14 centimeters. What's the length of the long diagonal? So I always like to draw a picture when we get questions like this here so that it makes it a little bit easier to see and digest. So let's draw a picture of this. So there's my best attempt at a kite here. So it's got side lengths of 12 and 16. So that means these longer ones here are 16 centimeters. And these short ones here are going to be 12 centimeters. Right? And it's got the two diagonals in here. Right? And we're trying to figure out what this long diagonal is, but we also know that this short diagonal is 14 centimeters. So we know that all of these are right angles here. But since this whole thing across here is 14 centimeters, we know that from our previous page here, our previous piece here, it bisects the short diagonal. So this short diagonal here gets cut exactly in half. So if we take 14 and divide it by 2, that gives us 7. So we know that this piece here is 7 centimeters and this piece here is 7 centimeters. So with that, we're going to try to figure out what this long diagonal is here. So let's try this. Let's take a look at just this triangle right here. So we've got the 12, the 7, and then we're going to figure out what that is right there, right? So hypotenuse there is 12, so this is going to be equals 12 squared. So we got x squared plus 7 squared is 12 squared. So x squared plus 49 equals 144. Subtract 49 from both sides, and we get x squared is 95, right? So then what we got to do here, so we're calling this here x. Got to figure out what the square root of 95 is here, right? So second square root 95. And we get 9.7467. So let's call that 9. 3 significant figures is right there at the 4th. 6 tells the 4 to get bigger. 9.75. Right? So we are figuring that's pretty close to 9.75 right here. Now we have to figure out what this piece is right here. And then we can add those two together. Let's call that y since this is x. We can add those two together, and that will tell us what the long diagonal is, right? So in this one here, let's redraw this triangle right here. So we've got that 7 right here. We don't know what this is. This is our y. That's what we're trying to figure out. And then we know that that diagonal there is 16 centimeters. Okay, so we can do, again, the hypotenuse is the 16 here. All right, and then we got 7 squared plus y squared equals 16 squared, right? So 49 plus y squared. 16 squared is, I believe, 256, right? So subtract 49 from both sides. And we get y squared is going to be, let's see, let's borrow one there. 207, right? So square root both sides, and we'll get that y is the square root of 207. Square root 207. And we get 14.387. Let's see. Let's do this. This one was rounded to the nearest hundred, so let's just round this one to the nearest hundred. 7 tells the 8 to get bigger, so 14.39. Right? So to figure out this total diagonal here, we've got 9.75 plus 14.39. And let's do this. So we got 9.75 plus 14.39. Yeah. Gives us 24.14. If we round out to 3 significant figures, we get 24.1 centimeters is the length of the long diagonal on that one. Okay. B, a rhombus has side lengths of 17 millimeters and a long diagonal of 26 millimeters. What's the length of the other diagonal? So same idea. Let's draw a picture. That's my best bet on that. And then let's draw the diagonals in there too. All right. Side lengths, so all these are 17s. And these are millimeters. All right. And let's see, the long diagonal is 26. So on both the square and the rhombus, it also bisects these pieces here. So if the whole bisects the diagonal, excuse me. So if this long diagonal here is 26 divided by 2 gives us that each piece of this long diagonal is 13 millimeters as well. Okay, so now all these are right angles. Now we're just trying to figure out how long this other diagonal or the short diagonal is going to be, right? So if we just take a look at just this piece here, we've got that this is, ooh, that's bad. Okay, there's our right angle. This here is 17. This is 13. And that's what we're looking for, right? So our hypotenuse is 17, so that's 17 squared. And then the other two sides are x squared and 13 squared, right? So x squared plus 169, 17 squared. I don't remember that one. 289, so equals 289. Subtract 169. And we get that x squared, just this part right here, which is just that. There's our x, is going to be 120, right? Yep. Okay, so now to figure out what plain old x is, we got to square root both sides, right? So we get x is the square root of 120. So square root of 120, and we get 10.9544. So the 5 tells the 9 to get bigger, so we'll call it 11.0. Right? 10.95, yep. So we get that this is about 11.0. So this here is going to be the exact same. So that's also 11.0. But really our best bet here is to take our original number here, and basically we just need to double it, right? So times 2. You'll notice we're not going to get 22. We actually get 21.90. 3 significant figures is 21.9 millimeters is going to be our the short diagonal here. Okay, then, and this here is a good example of why you always want to use your non-rounded number until the very end, when you can round it after you've done all your calculations. Okay, let's look at some other important information here. Some special triangles. We have this here and this here. So this here is isosceles because it's got 2 sides the same. And this here is actually an equilateral triangle because it's got the double lines on all of those. So all 3 of these sides are the same. So with both of these, the altitude, which is the height, right, bisects the base at right angles. So you drop this straight down, and this makes right angles here, and also cuts this side in half. So same thing here. You drop this straight down, makes right angles, and cuts this bottom part here exactly in half. All right, example 6. Find the altitude of an equilateral triangle with sides 6 meters long, and then find the area of the triangle. So let's draw an equilateral triangle-ish here. All right, that looks fairly equilateral-ish. And these are all 6 meters. Right? So with that, what we want to do is we want to create an altitude here, which makes a right angle on both of these, and it also cuts this exactly in half. So if this whole thing is 6, this is going to be 3, and this is going to be 3. Okay, so to find the altitude, again, if you look at just a part of this here, which will be, this is our 6, this is our 3, there's our right angle, there's our x. Sorry for the wonky side there, but hypotenuse on this here is the 6. So we got 6 squared's our hypotenuse, and then we've got the other two legs. We got x squared and 3 squared, right? So x squared plus 9 equals 36. Subtract 9 from both sides, and we get x squared is going to be 27, right? So we square root both of those to get that this altitude here is square root of 27. Square root of 27 gives us 5.196, so let's call it 5.20. And that's meters. Okay, so there's our altitude. Now we also have to find the area of the triangle. So let's, instead of calling that S, okay, altitude equals 5.20 meters. That's our better answer instead of x, even though that there is x. So in order to find the area of a triangle, area is base times height divided by 2, right? So base of this triangle here is going to be 6. The height we just figured out is 5.20. And divide that all by 2, and away we go. 1/2 base times height, right? So now here's the thing. This 5.20, remember, was rounded off. So this is the non-rounded number. So I just need to take 6 times this number. So I'm just going to do this times. If I just push the multiply button, it will take our answer and multiply it by, and we push 6. And that gives us 31.17, blah, 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 blah. And we want to divide that by 2 to get what our area is, 15.588. So the 8 tells, here's the 1, 2, third significant figure. So the 8 tells the 5 to get bigger. So I'm going to call that 15.6. 15.6. And it's meters. Since it's area, it's meters squared. Okay? All right. One last concept here is circles. Okay. A tangent to a circle and a radius is drawn to the tangent meet at a right angle. So basically, if you've got a center, from the center of the circle, you draw a line out here, and if you've got this tangent piece, tangent is a line that just touches the edge of a circle just once. This is always going to make a right angle, okay? So you can actually then make a right triangle by drawing this dotted line here, and the line from the center here is our right angle, and there's our hypotenuse, okay? The angle formed by a semicircle is always a right angle, okay? So if you basically pick any point on this circle, it's supposed to, well, semicircle, and you draw, so we pick this point right here, and you draw the 2 from each end of your diameter. Sorry, not diameter, but yeah, no, sorry, diameter, I was right. Draw from the ends of the diameter to the point, and that will always make a right angle. Okay, and then the line drawn from the center of a circle at right angles to a chord will bisect the chord. So remember, chord is a line that starts and ends on the circle. Okay, so if you've got a chord here and you draw from the center of the circle, and let's see, drawn from the center of the circle at right angles to the chord will bisect the chord. So basically you just draw this radius straight down to that there, and that will make right angle, and that cuts the cuts this chord exactly in half. Okay, so using that information, let's try these two questions here. Example 7. A circle with radius 7 meters has a chord length of 6 meters. Find the shortest distance from the center of the circle to the chord. So let's do this. Let's draw ourselves a circle, draw all of our important information here, and then let's figure out what we can do with that. Okay, here's our circle, and we'll say it's got a radius of 7. Right, and then it says it's got a chord length of 6 meters. So let's do this. We'll make a point there and maybe a point there, and we'll draw a chord between those two. Right, if we draw this here, that's another radius. We know that these are both 7. We know that this line here is 6 meters. It says find the shortest distance from the center of the circle to the chord. So from the center of the circle to the shortest distance from the center of the circle to the chord is going to be this right here, which we just found out that makes a right angle, right? And it also bisects this. It cuts this side here exactly in half. So this now is going to be 3. So if we redraw that triangle there, there's our 7. Let's see, there's our 3, and that's supposed to be our right angle. Didn't quite work out, but you get the idea. So that's 3, that's 7, and then we're trying to figure out find the shortest distance from the center of the circle to the chord. So there's the center of the circle, there's the chord. We're looking for that there. Okay, so the hypotenuse here is 7, so let's make that equal to 7 squared. And then the other our two legs are x squared, or x and 3. So we'll do x squared plus 3 squared equals 7 squared. X squared plus 9 equals 49 minus 9. Subtract 9 from both sides, and we get x squared, is 40. So we square root that, and we get that shortest distance is square root 40. And that gives us 6.324. Third significant figure, 1, 2, 3 is 2. 4 tells the 2 to stay the same, 6.32. And that is meters. And that's just a distance, so 6.32 meters. Okay. Last one, find the value of x. So we've got a semicircle. The reason why you can tell it's a semicircle is it gives you this dot right here. That's always going to signify the middle of the circle. So that means that this is a semicircle. So if this is a semicircle and you got a point on that semicircle, this has to be a right angle. Okay. So we're looking for this side x. We have this side is 7, and we need to figure out what this hypotenuse is. So this here is the radius, which is 4. So that makes this the diameter, which is just going to be twice 4. So that means that this is going to be 8 centimeters, right? So we're looking at this triangle here. Hypotenuse is 8, so it's going to equal 8. And we square it. The two legs are going to be x and 7. So we get x squared plus 49 equals 64. Subtract 49 from both sides, and we get that x squared is going to give us, what, 15? Okay, and then we got a square root both sides. So this length, this value x here, is going to be the square root of 15. Square root of 15, and we get 3.8729. First, second, third significant figure. 2 tells the 7 to stay the same. 3.87. 3.87 centimeters is going to be the length of x. Okay? All right, that's all there is for this section here. If you have any further questions, please feel free to ask in class. Thanks.